guys, this is Academic Chemistry Chapter 4, Section 3, Distinguishing Among Atoms. So if we're going to be talking about distinguishing or determining the difference between atoms, that means you're going to need your handy-dandy periodic table. So please make sure you have your periodic table out. You're also probably going to want a calculator. It's just, the math is pretty easy, but in case you don't feel like doing it in your head. So please make sure you have periodic table and a calculator to get these notes started. Okay. So the first thing we want to talk about is what the heck is the atomic number. So when we talk about the atomic number, it's the amount of protons in the atom's nucleus. So remember, protons are those positively charged things hanging out here in the center. So they're shown as blue on here. I mean, that's just this model. They may not always be blue, but they are those positive charges right there in the center of the nucleus. This determines the identity of the element. So if something has 7 protons, for example, it is nitrogen, and it's never anything else. If anything has 7 protons, it has to be nitrogen. If it has 8, 9, 10, it can't be nitrogen. It never, ever, 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 ever changes for a given element. So an atom of nitrogen is always going to have 7 protons, no matter what ever happens. All right, if you look at your periodic table, the atomic number is the order on the periodic table. So if you find oxygen, so O, oxygen, has an 8 here. It's that whole number where it goes up by ones. So 8 is for oxygen. That is the atomic number for oxygen. It's the number of protons. Every single atom of oxygen always has 8 protons. So if you look at your periodic table and you start reading it like a book, so if you start on the left-hand side and go to the right, you'll notice hydrogen has 1 proton. Helium has 2 protons. The next one, so any atom with 3 protons, would then be lithium. So it always goes in order 1, 2, 3, 4, 5. That's the atomic number. So if I asked you a question that said, which element has 19 protons in each atom? Well, what you're going to do is you're going to read this 1, 2, 3, 4, 5 until you get to 19, which is right here, potassium. So potassium has 19 protons in each atom. So if you have a sample that has 19 protons, it has to be potassium. It can't be anything else. The next thing we want to talk about is the mass number. Now, you know the word mass. We've talked about that before. That's how much matter in an object. So you find like the grams, kilograms, things like that. A number is like a counting number, 1, 2, 3, 4, 5. We've talked before that most of the mass comes from the protons and neutrons. So the mass number is saying how many of those are there, or the sum of the protons and neutrons, the sum of the things that give the atom mass. Remember, the electrons are so eensy-weensy tiny that they're so insignificant in size, they don't give any mass to the atom. So the protons and the neutrons, so we say the mass number, what's the number of things giving the atom mass? Now, these are the total number of nucleons. If you remember, all the mass, pretty much all the mass in the atom comes from the nucleus. It is super dense and really, really tiny. This is just saying how many things in that super dense, really tiny area are there. You may have a different number of neutrons in a given element making different isotopes. So we could have carbon-12 has a mass number of 12. It has 12 things in the nucleus. Or carbon-14. Carbon-14 has 14 things in the nucleus. So there are 2 more neutrons. If the mass number changes, it has to be the neutron that changes. If the proton changes, it's a different element, right? So in the same element, you might have different numbers of neutrons, and that creates different varieties of the same element. They still have the same chemical properties because it's the same element, but maybe a little different masses. One might be like radioactive while the other isn't. We'll get to that if we ever talk about radioactivity. All right, very similar, so do not confuse these. Very similar, so don't confuse these, is the atomic mass. So before we said the mass number says how many, the atomic mass is the actual mass. So the mass of an atom, and this is expressed in atomic mass units or AMUs. You don't talk about the kilogram or the gram because atoms are so incredibly small that even if you put a prefix in front of it, it just becomes kind of obnoxious to talk about grams when you're talking at the nanoscale. Each proton and neutron has about 1.007 atomic mass units. So that's pretty close to 1. The atomic mass and the atomic number are going to be very similar, but the atomic mass is actually measuring the amount of matter in there, whereas the atomic number says how many things are adding up to make that, okay? So electrons, remember electrons are so incredibly small that we don't consider their mass as part of adding to the mass of an atom. I want you to think about if you were to stand on a scale to find your weight, right? Mass and weight are kind of similar. If you were standing on a scale and you're reading the number, and then this teeny tiny fleck of dust fell on you, would that number really change on the scale? Not in any significant amount, right? It wouldn't change enough for you to notice it. And that's like the electrons. The electrons are these teeny tiny little subatomic flecks. They're barely any matter. They're basically just charges with like this. So since there's so little bit of matter in it, we don't add that into the atomic mass. It doesn't even show up on our calculations. All right, if you look at the periodic table, remember this 8 was the atomic number, how many protons, and for oxygen we have this 15.99 number. That's the average atomic mass. So it shows the average of all the isotopes of that element. Remember, you have different isotopes of oxygen. You might have oxygen 16, you might have oxygen 14, oxygen 18, and that's depending on how many neutrons are in each of the atoms. If you average that up, on average, the atomic mass is 15.99 for oxygen. Now, how do you write all this stuff quickly? So we don't want to sit here and write, oh, chlorine, and the atomic number is this, and the mass number is this. We want a quick way to write all this stuff. So there's two ways to write quickly. The first is shorthand notation. So a shorthand notation might look like this. Whoa, lots of stuff. So let's break this up. The first thing is, if you look on your periodic table, you already know this. This is all the elements. And all the elements have a symbol. That's 1 or 2 letters that tells you what element it is, which is obviously a heck of a lot shorter than writing the whole name. So instead of writing chlorine, the first thing you write for shorthand notation is its symbol, Cl. Make sure it's a capital first letter, and if it has a second letter, that's always lowercase. All right, so then we go over here on the left-hand side. Notice this is not a fraction. Don't put a bar between these, okay? You've got 2 different numbers. The top number is your bigger number. That's your mass number. This is the total number of protons and neutrons. On the bottom here is the atomic number. This is the total number of just protons. Sometimes you won't see this number because for chlorine, for example, it's obvious the atomic number is 17. It can't change or else it's not chlorine. So some people might skip this. Now, if you're ever writing an answer on a test or quiz, write both numbers, but my problems might skip this number as like, you know, just an extra little piece of the puzzle. You'll see that later in the notes. And then we also have this up here. This might be absent, but this is the charge. If you don't see a number, if you just see a negative, that means -1. If you just see a positive, it means +1. If there's more than one overall charge on this, it would be called an ion. Then it would, like say if it's -2, it's written 2-. If it's +2, it's 2+. But if it's not there, that means that the atom is neutral. So there is no overall charge on that atom. So their other way to write it is going to be hyphen notation. So hyphen notation takes this form. You write out the whole element name, and then you put a dash, put the mass number, and if there's a charge, you put it up high. So if we were to take this shorthand notation and bring it down and write it in hyphen notation, the first thing you write is the element name. Cl is chlorine. The mass number is this top number, 37. And do we have a charge? We do, -1. So you put a negative. So this would be chlorine 37 and a dash. The most important part of this is this 37 tells you the isotope, right? The mass number is going to be your way to figure out the number of neutrons. So you have to say which isotope of chlorine you have. All right, so what is the shorthand for palladium 108? I want you to freeze this video for a second, try and answer this, and then I'm going to come back in a second and explain it. All right, so I hope that you froze the video. So if you were doing this, first palladium, you would find it on the periodic table and see that the symbol is Pd. So that's the very first thing you would write. We don't have any charge because I don't see a charge listed here, so this stays blank. 108 is your mass number, so that goes on top, 108. And then when you found palladium on the periodic table, you would see that it's atomic number 46. So you put a 46 down here, you've written it in shorthand. All right, let's do another one. What's the shorthand for iodine 130? Again, I want you to freeze the video and then we'll come back and go through the answer and see if it's what you got. All right, iodine has the symbol I. 130 comes from the mass number here. 53 is the atomic number. For shorthand, you always have the bigger number on top and the smaller number on the bottom. It's contrary to what you want to do because you're used to fractions, but remember, this is not a fraction. So it's okay to have a bigger number on top, smaller number on bottom. And you'll see later when you solve problems why that actually helps you to have the mass number on top, the bigger number, and the smaller number on the bottom. It sets you up to answer some other questions. All right, so here's where we're going to be answering those questions. So at first, I'm going to give you a little cheat sheet on how to find answers. So always come back to this if you're wondering what to do. Remember that protons are equal to the atomic number, so you find that in your periodic table. And that's going to be those counting numbers that go in order on the periodic table. 1 hydrogen, 2 helium, 3 lithium. Okay, so that goes right in order. To find the number of neutrons, you're going to do the mass number minus the atomic number. Remember just a second ago I said it's nice to have the big number on top, the small number on the bottom? That's because it's set up right there for subtraction. If you want to find the number of neutrons, top number minus bottom number, boom, you're set up to find number of neutrons. Mass number, number of protons plus the number of neutrons. Atomic number, number of protons. This all kind of repeats each other here. I just wanted to put it out in different ways so that you have every way to find your answer. All right, for electrons, it's a little more complicated. When you're going to find the number of electrons, you have to look at the charge. Remember, the protons can't change, or else it changes the identity of the atom. The neutrons have no charge, so that won't relate to the charge. That just determines the isotope. It's the electrons that can come and go, and that'll determine what charge your atom has. So, if there's no charge, the number of protons has to equal a number of electrons. Protons have a positive 1 charge each. Electrons have a negative 1 charge each. So if you have 1 proton and 1 electron, then you're neutral. They cancel out. Okay, so that's a neutral atom of hydrogen. 1 proton, 1 electron. How about helium? Helium has 2 protons. So to cancel that out, you need 2 electrons, and then you're electrically neutral. But what happens if you have a charge? Well, to find the number of electrons, here's your formula. If there is a charge, take the number of protons, that never changes, subtract the charge, and that gives you the number of electrons. We're going to do some examples, but let me explain this. If you have an uneven amount, let's say you have 10 protons and 11 electrons. You've got positive 10, negative 11. 10 of those will cancel out, and you're left with 1 extra electron, which is a negative 1. You would have an overall negative 1 charge. So if you have more electrons, you have a negative charge. If you have more protons, you have a positive charge. All right, to find the charge, take the number of protons and subtract the number of electrons, and that'll find your charge for your overall ion. So let's do a practice problem together, and then you're going to do some on your own. So what about an atom that has a mass number of 56 and an atomic number of 26? Let's ask some questions. First, what is the element? Well, which of these determines what the element is? Would it be the mass number or the atomic number? The periodic table goes in order of atomic number. So you're going to find iron as number 26 for the atomic number. So here's what it looks like. 26 is what tells you. Notice the mass you see here isn't 56 because this is a specific isotope. It has 56 nucleons. This is the average. There are ones that don't have 56 nucleons, so this isn't always going to be the one you're talking about, right? This is an average of things you see all around the Earth and the universe. Next question, how many protons? If you look back at your cheat sheet, the number of protons is equal to the atomic number, which is right here, 26. How many neutrons? Go to your cheat sheet. If you take the mass number, number of protons and neutrons, and take away the atomic number, number of protons, you're left only with neutrons. So mass is 56 minus 26. That's 30 neutrons. And last, how many electrons? We don't have a charge, so the number of protons has to be equal to the number of electrons, 26. All right, let's do another one. Uranium-238. So this is written in hyphen notation. I want you to freeze this and see if you can figure out how many protons, neutrons, and electrons. All right, so we're back. How many protons? First, you need to find uranium on your periodic table. So that is right here. Uranium's atomic number is going to be the number of protons. So how many protons? 92. How many neutrons? Here's your mass. Don't look at the mass here. I know they're very similar. Don't look at that one. It's the one given to you in this specific isotope minus 92. So 238 minus 92 is 146 neutrons. And how many electrons? Well, there's no charge listed here. So if there's no charge, then that means the number of protons and electrons have to be equal. We had 92 protons, meaning 92 electrons. All right, let's do another one. So this one is set up in shorthand notation. I want you to try, freeze it, and I'll be back in a second to explain and see if you got the right answers. All right, so F on the periodic table is fluorine. So how many protons? Right here, it says 9. How many neutrons? If we had written this in proper shorthand, we would have a 9 here. And you notice you could do 20 minus 9 set up for you. So 20 minus 9 is 11. This isotope of fluorine has 11 neutrons. Not every fluorine is going to have 11 neutrons. This one does. How about how many electrons? Well, we have a charge. So we have a formula for that if you have a charge. Take the number of protons and subtract the charge. Notice the charge is -1. When you subtract a negative, it's like adding, so that's how you get 10. Another way to think about it is the charge is negative. So you need one more electron since electrons are negative to get -1. If I just had 9 electrons, I wouldn't have a charge here. So I need one more electron to get an overall negative charge, which is 10 electrons. All right, here's another one. Freeze it. We'll be back in a second with the answers. Strontium 86 with a +2. Find it on the periodic table. That gives you right away, boom, your atomic number, which is the number of protons, 38. How many neutrons? Always take this big number in the isotope. Do not look at the mass on the periodic table. That is the average atomic mass. We're only talking about strontium 86. And you take away the protons. So 86 minus 38 is 48 neutrons. How many electrons? Well, I have a +2, which means I need to have 2 more protons than how many electrons I have. I can't change my number of protons. So that means I have 2 less electrons than I have protons. So that way if I had my protons and my electrons, I have to have more protons to have more positiveness, to have an overall +2. Or I can do my formula, 38 minus the charge. My charge here is positive, so it's just 38 minus 2, which is 36. All right, zinc 70. Freeze it, we'll be back with the answer. All right, here it is on the periodic table. How many protons? Well, it comes from right here, 30. How many neutrons? Do not look at this. Always look at your specific isotope, which is 70. Now, if this was written in proper shorthand formation, you would have a 30 right here. So you can easily set it up to say 70 minus 30 gives you your number of neutrons, 40. How many electrons? We have an overall +3 charge. So you always do protons minus charge, so 30 minus 3. You can also think you need to have 3 more protons than you have electrons, because you need more positive protons. You can't change the number of protons. So you must have 3 less electrons. So it's 27 electrons. All right, that's it for this lesson. Good luck, and make sure you ask your teacher if you have any questions.